All right, guys, some of you said that you got a lot out of the mini lesson I did last week. It helped save some time. So I'm hoping to shave some of that time because obviously you guys are busier than I thought you would be with all the work you're doing. Okay, so I hope this helps out. This is my basic intro to Trig. Now, we, as students, as you approach this Trig level, you get all afraid, you get all nervous. Trigonometry, I think it's just because it's a hard word, where really we're going to learn some trickier stuff than this moving forward, Math 3, pre-calc and calc. So don't be intimidated. Really see if you can open your mind and not be intimidated by this, okay? All this is, trigonometry is just the math of triangles, okay? It's just the math of triangles, because triangles have certain relationships we could depend on. Triangles have all these angles add up to 180 degrees, right? And in particular with trigonometry, we are going to have about 80% of it, of what we're going to deal with, especially to start. In fact, most of it till we get to law of cosine and law of sines. Most of it to start is just going to be with right triangles. Right triangles, remember, have 90-degree angles. They have this right triangle denoted by the box. And we know a few things about the relationship between the sides already, okay? So there's a couple things we're going to do. I think this first part is a review. It's the Pythagorean Theorem, okay? Pythagorean Theorem is the relationship between these sides. Now, one side has this very special name, very special position in the right triangle. It is across from the right angle is the hypotenuse, okay? We always call that C. We always call the hypotenuse C, okay? We're going to call these other sides A and B. It does not matter which is A and B. Only C matters. Hypotenuse has to be across from the right angle, okay? So when we have this triangle like this, it's a right angle, a right triangle. I know that C, my hypotenuse, is across from the right angle. I'm going to call these A and B. And you say, well, I don't know. I don't trust you. Yes, this could be B. This could be A, and everything is still the same. A and B, it doesn't matter. I don't even care. Nobody cares. A and B. If someone's taught you that this has to be A, that has to be B, they've lied to you. Okay? So when you have A, B, and C, we know the Pythagorean theorem is going to have a relationship where we square the length of A, we square the length of B, and that equals the length of C squared. Okay? So Pythagorean is going to be something that comes up. You know, if they gave us like a triangle like so, where they say this is 5 and this is 4, right? We want to know what this, we'll call it B value is here, okay? And sometimes, you know, we label these A, B, and C, but they may be, you know, they may say that's X. It doesn't matter. We use A, B, and C to label and apply the Pythagorean theorem, but these could be numbers, these could be values, these could be expressions. C could be X plus 5. This could be X squared minus 3, right? These could be lengths denoted through expressions as well. But if we have this situation, we just have to start by saying, well, which is my C value? C value. Always start with that. We'll call this A, we'll call it B. Now we're ready to take those values, A, B, and C, and put them into the Pythagorean. 4 squared plus X squared is equal to 5 squared. 16 plus X squared is equal to 25. Subtract 16, and we get X squared is 9. You take the square root of both sides, and you end up with X is equal to plus or minus 3. Now I put plus or minus 3 because in our definition of taking the square root, remember that the square root of 9 is saying what value times itself gives us 9. 3 times 3 gives you 9. Negative 3 times negative 3 gives you 9. But which of these answers am I going to keep and which am I going to forget about forever? Think about it. We're talking about lengths. These are shapes. This is size. You could actually cut this out with a piece of paper and look at it, touch it. So how many of you can cut out a triangle with a side of negative 3? If you can do that, you need to quit high school immediately and get a job at Google because you can revolutionize the world. Sides cannot be negative in you know, standard Newtonian physics. Sorry, I went way too far with that. So we're going to just keep, because it's lengths, we're going to keep the positive measures. Okay, so 3 is my answer for this side. That equals 3. Okay, and we know this is what's called a Pythagorean triple. You know, 3, 4, 5, Pythagorean triple. The sides will always work out within a right triangle for these to work. What else do we have? We have, Well, you know what? I'm not going to go into Pythagorean triples. That's going to come up again later. Okay. So this is the basics about trig. Now we need to learn the most important word that you will learn in trig. Okay. All right. Let's look at this. So, ka, to, SOHCAHTOA. SOHCAHTOA is our map. If you remember SOHCAHTOA, which at first you're like, I can't remember that word, but every single student I've taught, and there's been thousands of them, has been able to remember SOHCAHTOA. There's no way to say SOHCAHTOA with different letters. If we look at the letters here, we'll start to maybe see a trend, because S, guess what, is gonna give us information about the sine function, not sin. This isn't church. It's not sin, it's sine, like a stop sign, okay? Ka. What do you think C stands for? Think of those trig buttons you've looked at and never understood. Ka. The C is talking about the cosine, okay? T, which function, button you've never used before are you going to use here? Tangent. This is the tangent. So, you know, if I were to spell these out all the way, we always use the three-letter abbreviation, but this would be the sine, this would be the cosine, cosine, this would be the tangent, right? So you never write them all the way out, but that's what this is talking about. These are looking at the three different types of trig function, okay? So we have the sine, like a stop sign, the cosine, like you're cosigning a check, cosine, and the tangent, okay? Cosine doesn't have any relationship to sine, as in it's the or like the like co-captain kind of thing. Not at all. Cosine is just they're separate. They don't relate to each other like that. Okay. Now let's look at this. SOHCAHTOA, our magic word. Now there's going to be another word I'm going to use. It's called theta. Okay. Theta. Theta is just an angle that I don't know about. It's an angle in question, theta. I don't know about it, okay? Now, we're gonna learn next that O and H, A and H, O and A, H, and A, O, and H are the three letters we're gonna always deal with. O, A, and H. Let's see what they mean. This is opposite, okay? This is hypotenuse. And I wanna pause. Really try to focus on this. This is the key. This is the key right here. If you're talking negatively to yourself, forget that, boys. Focus here. Everyone can learn this, okay? So SOHCAHTOA is our magic word that tells us how everything works together. The sine, OH, so, opposite, hypotenuse. Cosine, A is adjacent, right? I'll write it out. Adjacent. H is hypotenuse again. O is still opposite, A is adjacent. That's how I'm going to write it from now on, ADJ, okay? So we have the opposite, we have the adjacent, we have the hypotenuse. Those are the three sides to a triangle in reference. All of this is in reference to theta. So for instance, let's look at what I mean by that. If I have a right triangle like this, right? First off, you want to always look first. Where is my theta? Where is my theta? Because you can get the entire problem wrong if you assume, okay? So I'm going to go ahead and put theta right here. Theta, okay? Now, they may have it where, you know, they're calling this A, B, and C, which corresponds to side C, side A, side B, right? But it doesn't matter. Don't pay attention or try to make rules based on how these vertexes are labeled. Forget that. It's easier than that. I promise you, okay? All you have to do, number one, step one, where's your theta? We found the theta, it's right here, okay? Next we need to identify the opposite, the adjacent, and the hypotenuse in relation to this angle. Now, I'll tell you what, there's one that's always going to be the same one. Which is going to always remain the opposite, adjacent, or hypotenuse? Is there a side that always fits into the same category? Yes. This is always the hypotenuse because the hypotenuse is across from the right angle. Okay. We break this down slowly. You start to understand it. Okay. Here is our theta. This is our angle in question, right? So which angle, or excuse me, because we're talking about sides, all the sides are opposite, adjacent, or hypotenuse. Now, which is the opposite side to this angle? Which is the opposite side? And you may say, duh, it's over here. But this isn't a duh moment. This is a moment where you really got to get this 100%. Because I've seen over the years, folks will be looking at this angle and say, oh, the opposite angle is this, excuse me, the opposite side is this side. No, this angle here, think of it this way. I like to teach it this way. If you had a projector, right, at the vertex of our theta, where is the projector going to project? The projector will always project on the opposite side. Doesn't that make sense? Like if you're standing in a corner, you have a projector. Is the projector going to somehow magically turn and the light is going to turn and project on this wall? No. The opposite is always on the opposite side of the triangle. You may say that's really easy, but for those that needed that extra benefit, you know exactly what I mean. Okay, that little extra description. Okay. So we have the projector out of there because we already figured out what the opposite is. I always like to find the hypotenuse, label it right away, right from across from the right angle. It's always going to be across from the right angle. The opposite, I think of my projector. It's going to project on the opposite side. The adjacent is a little harder to see, so I leave that for last. So get the hypotenuse out of the way, get the opposite out of the way. The adjacent is what's left over. Okay, this is going to be in our adjacent. Okay. And after you start, doing these so often, just say that's H. Here's my theta. So I'll say it's opposite. That's adjacent. You can just label it AOH. That's fine. But if you like to be a little more thorough and remind yourself as you do this, once you get used to it, then label them, hype, op, adjacent. Okay. Now, here's the thing. Here's the thing. I want you to think about this. Now, SOHCAHTOA is in relation to theta, right? And what we're going to learn here is that the angle, how far this opens up. Now think about this. My first question is, if the angle instead of being this wide, right, was only this wide, would the opposite side be larger or smaller? Think about that. Here's the angle right now. Theta is this degree measure. If I close the angle a little bit, make that theta smaller, is the opposite side going to get bigger or smaller? The opposite side is going to get smaller, okay? So the angle in a triangle is related to the lengths of the sides. So if I lowered this down, I'd see that my hypotenuse would become a little bit smaller, right? It shrunk a little bit because I moved the angle opening. The opposite went from being this length to less, right, as the angle becomes smaller. Because what we need to know is that angles have a correlation to the length of the sides in a triangle, okay? So if I had a triangle like this, right, it's still a right triangle. This angle, think about, this is like, it's gonna help, trust me. This angle here is obviously smaller if I were to make a larger triangle like this to that angle, right? And the corresponding sides, this side is the same for both of these red and black triangles, but the other sides, this side is much shorter than that. The hypotenuse is going to be slightly shorter than this, okay? So the two triangles depend on what our theta is for each of those triangles. All right, let's bring it all together. All together. Okay, bring it all together. All right. Let's draw a triangle over here. All right, let's say that this is 10, and let's say that this is 6, right? And I have my theta right here. Here's my theta, right? So first thing that we always do, where's my theta? Where's theta? We got that. We know which one it is, okay? Next step, number 2. Label our opposite, adjacent, and hypotenuse, Okay, so let's go ahead and label these. So it looks like here's the 90 degrees. So this is my hypotenuse. Okay. Okay. Here's my theta. So the projector projects on the opposite side. The opposite side. And guess what? Adjacent is always left over. Edmodo. Stop it. Why? Somebody needs help or something. Quit bothering me. Just kidding. All right, so we have adjacent, opposite, hypotenuse all set up. Now, here's the thing. If I want to know, right, let's even give this a value. No, I'm going to leave this. I'm going to we'll just leave this as A, okay? So here's the thing. If I needed to know the sine, right, of theta, what we're doing today and for this lesson is we know a little bit about SOHCAHTOA, right? How they have sine is opposite hypotenuse, but what I didn't show yet is that the sine has a ratio. These are the ratios. They're the fractions. The sine is the ratio between the opposite over the hypotenuse, okay? The sine is the opposite over the hypotenuse. What do you think the cosine would be? We'll do this one next. The cosine has the ratio of the adjacent side length divided by the by the hypotenuse side length. This is going to be adjacent and hypotenuse. Here's the thing. Once you have labeled correctly, all this is going to be is plugging in the correct values to create our ratios that we need. Okay, so let's look at this. Sine of theta. The sine of theta for this is going to be, so I'm going to rewrite sine of theta because I don't know theta. I can't just put that in there, right? Sine of theta is equal to, okay, the opposite over hypotenuse. Opposite is 6, hypotenuse is 10, so we're going to go 6 over 10, which we just figured out the sine of theta is equal to 6 divided by 10 is 0.6, okay? So this would be one of your answers. You know, if I was just looking for the ratio for sine of theta, there's my ratio for sine of theta.